Okay, computing model continued. This is lesson 2 of the computing model section. Lecture, I should say, lesson 6B, because it's the second part of lesson 6. And this focuses on the developments after 2014, where we'll see cloud computing maturing and no longer being sort of somewhat doubtful and not totally adopted to something so trivially adopted it doesn't require mentioning. We will look into specific technologies like blockchain, which is a more emerging technology to do distributed transaction databases. Remember, this is the Big Data Applications Analytics course, and this is the motivation section. All right, hype cycle for cloud computing. And Gartner has hype cycles for everything. And you can see that this hype cycle is not so easy to interpret because it has, whereas the main hype cycle for emerging technology is full of broad concepts, this is full of pretty detailed things such as, I don't know, API economy. I'm not quite certain what that is. Container management is a pretty solid, straightforward subject. I don't know that I get excited about it. It's pretty important. IoT platform. That's a non-trivial area because of the importance of edge computing. Hybrid cloud computing. We've actually sort of looked at that already. Serverless platforms. That's pretty interesting. That's something we'll discuss a little later on. And software-defined anything is also important. That's what you need to have to be able to do software-defined systems. Cloud Office is presumably Google Docs and Microsoft Office 365. Cloud bursting is how you go from private to public resources. Private cloud computing we've mentioned. Platform as a service. Infrastructure as a service. Software as a service. These are the basic ways the clouds can be offered, quite wide or in that order of maturity, I'm not certain. Virtualization, that's what clouds are built on. I would not consider it that mature. It's OpenStack, the one we typically use, is pretty flaky. All right, notice this comes from Sweden. There was a talk by somebody from Gartner in a Swedish conference, and this was his slides. Notice these hype cycles are all sold in separate documents, each of which costs $1,995, so it's not something you're likely to buy. So you browse the web and hope to pick them up. All right, so here we have the trends that this speaker from Gartner identified going with that chart. That it says here you basically have to use clouds, otherwise you're going to fall behind the competition. You can't just wait any longer. You must plunge in and use the public cloud. No cloud policy or no internet policy are both incorrect today and will be more obviously incorrect in 2020. By 2019, 30% of the new software will have shifted to cloud only. They're not just cloud first, they're cloud only. For trivial reasons, you don't really want it to support multiple deployments. Half of the applications running in the public cloud will be mission critical. So that's pretty interesting. The clouds will be essential. That's by 2018. And by 2020, clouds will be the dominant expenditure area compared to mainstream. I know when I began working in this area, 2008 or something, that wasn't obvious. That was pretty controversial. And I like this one. 2020, only 5% of the cloud security failures will be due to the cloud. The rest will be your vice president for important things leaving his laptop on the bus or something. All right. All right, here we have 3 magic quadrants. We've seen this type of thing before from Gartner. They have challengers, leaders, ability to execute. Here we have niche players in the bottom quadrant and visionaries who are pretty good along the completeness of vision, but not really so complete as to be competitive in execution with the leaders. And we don't actually see any challengers in any of these quadrants. We see Amazon sitting at the top here, and we see Microsoft actually increasing each year. And we all see that in other graphs as well. Microsoft is doing pretty well. Google is slightly increasing, but not really as fast as Amazon. And we have Rackspace sitting in here, which is, people, we quite like Rackspace because they sort of invented OpenStack. So they're well known because of that. And here's VMware. So these are VMware offers a much more specialized service than the others. So it's put down there. It's doing pretty well as a company. It's just not a complete cloud infrastructure as a service company in the same way as Amazon or Microsoft or Google is. So this also comes from this talk in Sweden where this Gartner employee gave a keynote of some sort. Okay, that's it. We go on to the 2017 version of this in the next slide. And here's it's now become a computing magic circle, not a quadrant, but I think it's still a quadrant. And this is a better resolution. Amazon's still up the top. Microsoft, no better than it was in 2016. This is pretty recent, June 2017. Here's Google. It's almost crossing the line. And then back here, we have Alibaba, obviously a major Chinese vendor. China will only have Chinese clouds. IBM, Oracle, and Rackspace. It was the people who developed OpenStack originally. And I must admit, I'm not familiar with the others. But they're still niche players, so we needn't probably worry about them too much. So we have already a 3 to 5 horse race. Let's add Alibaba and IBM as horses of relevance. Here we have just 4 of the horses with market share in 2016. And Amazon is clearly more than all the others combined, 31% of the total. Here is Gartner's list of how they judge, how they form the magic quadrants or magic circles. They look at these capabilities, compute resilience, architectural flexibility. Do you have GPUs or not? Or do you have large memory or small memory? What about all your security and your way you manage your users? Way you integrate with enterprise systems? How about DevOps? Do you support Ansible, Chef, Puppet, etc.? Scaling, how elastic is it? And how does big data run on your system? Do you have great NoSQL databases like Dynamo and things like that? Use cases, how the various things needed for use cases are supported. Cloud native means that the application runs well on clouds. There are various articles around which tell you how to build cloud native applications. Then we have general business applications, in edge computing, the Internet of Things, batch computing, that sort of solid dominant need, as well as the opposite to batch is real-time or streaming computing. And we need to be able to develop our applications. Here is a graph from some rather, well, no, maybe not so interesting discussion of how you decide what clouds you need. Here and this moves up here from the bottom, where it's really at the very low level IT tasks. Here are the IT services, and here are the business services, where all the business services where your applications lie. And they're just recommending that you need to work back from what you want to do to what you need in these bottom layers here. And here we have provisioning, patching, configuration, and compliance and audit. So there is a document which describes this in detail. Comes from Gartner. Okay, this comes from the 2017 Internet Trends report by Mary Meeker. A lot of my slides come from that. And here we have the total IT infrastructure spend. And this tells you the fraction of private, public, and traditional. And not surprisingly, given the focus of this class and the way the world is going, the amount of public and private clouds is growing. It was 23% total in 2013. It is 37%. It's a very significant increase in 2016. This number here we'll see on the next curve corresponds to about $36 billion. So obviously, public and private clouds will overtake traditional data centers, not so far in the future. All right, here we have some actual numbers. The total cloud IT infrastructure, again divided between public and private, where again the public about 50% more than the private, so maybe the private is 40% of the total cloud, and the public is 60%, solid 13% annual growth. And here we're up near 60 billion for the total cloud infrastructure, which is again divided, as I said, roughly 60-40 public to private. Here we have a particular subset of the cloud market, infrastructure as a service, and we see here a strong growth, 38%. Remember the previous one was 13%, and we're up to 22 billion for infrastructure as a service in 2016. Remember the total was 38 billion for all of clouds in 2016 from the previous slide. So infrastructure as a service, which is a little surprising because it's the lowest level where the user has to do most, is growing the fastest. That's because probably some of these things like software as a service are not done very well and are a bit clunky, and infrastructure as a service allows you to do it better. Here's the strategy. I mentioned this number, the public to private was 6-4. But here in 2016 is private, that is this 30%, hybrid 23%, and public 47%. If you divide the 23% equally between public and private, which sounds reasonable, you will get roughly the 60-40 public to private ratio I quoted earlier. Remember, hybrid is private on the premises of your enterprise data center, going out to the public, so-called bursting out of the public for additional capability. All right, let's go. Here we are. I'm having trouble with this slide in quite understanding. I don't think it's quite consistent with some of the other slides. Here's 2014, and we have 36% traditional IT, but 45% private cloud, which seems very high to me because previous slides had lower amounts of private clouds. Here we have 19% public cloud, and that 19% is growing to 48% public cloud in 2019, and with traditional IT being 40% and private cloud being 38%. I think this slide is using a different decomposition between private and traditional IT, cloud and traditional IT, both of which are private systems than previous charts we had. I don't. So let's at least focus on this: 19% public cloud, going up to 48%. That's a pretty solid number. So here is an interesting plot telling us about in 2016 and 2017 where people are running. That's the blue things. In 2016 and green in 2017, and this graph here compares 2016 to 2017, showing Amazon maintains a constant usage. Microsoft, which is Azure, is growing very significantly. Is growing actually more than Google, and certainly a lot more than IBM. So it says Amazon is hanging in there, but Microsoft is doing very well, very aggressive. Even though they start off with the disadvantage of running Windows, they now have adopted Linux properly, and so they're actually very competitive with the other people. They have a very rich infrastructure. This one here is only in 2017, and it tells you about what they're running, which is the same as this thing here. Well, actually, this blue thing is the same as the green thing here, because this is the running applications, which is in 2017, which is the green ones over here. And then we have experimenting, planning to use. And we can see it's actually interesting that Google has the most people planning to use it, and IBM is the lowest, but Google is almost the same as Microsoft and not really that far ahead of Amazon. But Amazon and Google both have 70% experimentation and Microsoft 21%. So this says that you can expect IBM to increase, Amazon, in fact, to decrease probably, and Microsoft to go up quite a bit, and Google to go up probably a little. Pretty interesting. Okay, so this is a sort of more cosmic picture with some graphics telling you what the core ideas are. There are things like serverless computing, which are new ways of delivering software in all sorts of different ways, with software-defined systems and Share from Puppet and Ansible and things like that. Then we have containers, and we have microservices, which are instantiated in containers to simplify the software deployment. Then we have wonderful analytic databases, and namely a database like BigQuery attached to an analytical engine. And those are really quite important, and they have elastic bands because they can be expanded. And then we have a major driver for cloud computing, edge computing, which pushes the computing, to the edge. But more importantly, the data source is the edge, and that data will sometimes get processed on the edge, but also go back to the cloud. So cloud support to the edge is take the data where needed from the edge, which is sometimes processed data, and decide what processing to do on the edge and what processing to do on the cloud, and make that relatively seamless. For example, Amazon has a system called Greengrass on the edge, which is the same as Amazon Lambda, which is their elegant event-driven system on the cloud. And Lambda's on the cloud, Greengrass is on the edge, and they're same or similar APIs. This is just a sort of an amusing plot of what the ratio of designers to software engineers was in 2011 to what it is in 2017. 1 to 25 to 1 to 9. That's Atlassian, which is a well-known company supporting software engineering. Dropbox, which has already quite a high number of designers to developers. IBM, dramatic reduction. Dramatic increase in the number of designers per developer. It just seems to be a sort of universal number, somewhere between 1 and 5 to 1 in 10. And LinkedIn actually has always been pretty good with designers, and it hasn't changed so much, but it has got a little more focused on designers. Here we have the Amazon quarterly revenue. This is the only thing that is keeping the Amazon company even vaguely balanced. They lose money on their e-commerce activities because they keep on investing in new infrastructure and in Prime delivery and things like that. But the cloud computing keeps making money. Here we have the growth, which is here up here at about 60% maybe in Q2 2016. Here we have the actual revenue, the bars, pretty solid. It's almost $3 billion in Q2 2016, and it's a very very profitable business for Amazon. So this is how these public clouds are getting used and what the value of this usage. So here's Gartner saying the worldwide market for public cloud services is $204 billion, a growth of 16.5%. And we noticed before that infrastructure as a service, which is only 11% of the cloud computing total, is the fastest growing segment. Though I pointed out there are some reasons to doubt that, because Amazon services have become so complicated that for a real person to use infrastructure as service is getting harder and harder. Anyway, here we have these categories: business processes as a service, software as a service, supporting advertising, infrastructure as a service, cloud management and security, and cloud platform as a service. And these are the values in billions of dollars, and they're all growing nicely from 2015 to 2016. Here is the same number put in as a percentage growth, pointing out that then infrastructure as a service, which was relatively small total, is actually got the best growth, and business processes as a service is not doing so well. Cloud advertising is going to go, which is the dominant, the largest in numerical value, has a good solid 15 to 14% growth. And remember, this is 200 corresponds to 204 billion total, so pretty good chunk of change here. All right, now we switch to something different, as they say, blockchain. And that's here because it's implemented in cloud computing, but it's a technology, a very specialized technology, which has grown with lots of hype, and it's doing something very simple. It's just allowing financial organizations to do their job in this very distributed world we live. And that's what's in. Here we have a whole bunch of ledgers, each with records. They need to be kept consistent and reconciled across the globe. And traditionally, this is not so easy. Certainly, particularly hard as in Dickens' time, you have people writing them down in books, especially when you have mean people at Christmas persecuting you. All right, so we now want to actually automate this and integrate all these actions together. And we want to do this in a way that cannot be changed, has total finality, is well metadata, so we know the provenance of every transaction. Why did that transaction occur? It wasn't. So we can look for fraud, and if somebody queries something, we can look it up to see what happened. Provenance is particularly important here. All right, so we have contracts, privacy, ledgers. These are just the records being shared. And we need to get consensus, and again, that's much easier when you have a digital environment underlying all of this. And it saves time because it's automatic and it takes seconds. It removes all sorts of overheads. It reduces risk, less crime, less fraud, and increases trust. So we're all hopefully happy. It's hard to be happy. Maybe these days life is really quite dramatically full of stress. And then finally we have or nearly finally we have a list of all the one of these pretty pictures where you put down all the logos, and here is the particular consortium, the R3 consortium. You have Consortium Digital Asset Holdings, the Hyperledger project. This is just some of the members, and the Ripple project. So these are different consortia and networks of people working together in the blockchain area. Here is just a couple of slides on what people are doing. So what are they doing with in the European area? They're creating new businesses. They're improving their cost efficiency. They're trying to just investigate blockchain because it's so hyped. It's amazing that a rather straightforward database would be hyped, but that's life. We're worried about being disrupted by people who are using it and we're not, which is sort of similar to competitive pressure. And we're afraid of a growing of what's called a fintech, which are these financial technology companies. There are a whole bunch of startups doing financial technology. If you don't do it yourself, you'll have to buy a fintech. All right, the final slide of this lesson 6B, the initial use cases in the European area in the banking sector. Transferring money, not surprising. Nice ledger. Clearing securities, a nice atomic action. Know your customer, KYC. You have to know buzzwords in the area. AML, anti-money laundering. You didn't know that, did you? Well, maybe you did. Currency payments and settlements. Being transparent. Notarization. Notarizing is horrible. It's going to take your pieces of paper to have them notarized at the local what have you, which has a notary. I'm sure it's not the most efficient thing to do. Trying to dispel lower fraud because everything is so well specified. Producing registries of assets, lists of assets, and then issues, security issues, and coordination. So that's a set of pretty important, although not so maybe so exciting use cases. With that, we'll end lesson 6B in the cloud and other computing-related technology. Thank you very much.